derivatives. We're starting day one. Remembering all things derivatives. Remember the apostrophe means derivative, not to be confused with this notation as well, which means what?
Inverse.
Inverse. And when the apostrophe is associated with a lowercase letter, that usually indicates a function, not to be confused with a capital letter, which actually means like complement of a set. You think probability. Okay? Derivative also means slope, and we started out with the formal definition of a derivative, which is given to you in the reference booklet, which is very rarely used, but is where derivatives even derived from. Okay? So, we're going to do just one example using the formal definition of a derivative. Okay? Just to refresh your memory on how it's used, but from there we'll start going over all of the rules. So this one I do want you guys to get down into your notes. So just refresh your memory. It was the limit as h approaches 0 of x plus h. Sorry, f of x plus h minus f of x all over h. Okay, h, we evaluate the limit as h approaches 0. Okay, so if we were to plug in 0 right now, we would have f of x minus f of x all over 0, which is technically a 0 over 0, which we cannot have. All right, so when we use our formal definition, remember we always wrote the limit notation along with it. This first part meant what? What does this first part mean?
Plug in x plus h into every x.
That's right, plug in x plus h into every x that you saw. So you'll have 3 times x plus h squared plus 2 times x plus h. Then you had to subtract the entire function. Make sure that you include parentheses around the entire function so you know to distribute over that negative. It was at the very beginning. You should.
You should.
That's where we crossed the burning sands into calculus land. Using the form, I had you do a whole long period day of formal definition.
I remember that day.
And then I showed you power rule, and y'all were like,
So upset. You ever heard of that thing where like your brain just automatically blocks something out because of the trauma it gave?
oh my goodness. That's okay. What do I have to do with this squared here?
PTSD.
Yeah,
foil it.
I need to FOIL. So as the limit as h approaches 0, this becomes 3 times x squared plus
2h plus h squared.
2xh plus h.
Dang it.
What do I do to the 2?
You foil it with x plus h.
So that'd be 2x plus 2h. And then with the negative, I need to distribute. I remember this showed up in a problem in an old SL exam where you had to show that the derivative was what we're actually about to get to using the formal definition. So you want to make sure you don't skip any steps because you never know where the points are going to come in the show problem. What do I need to do to the 3? Distribute. And what do you see once you distribute over that 3?
A bunch of terms you can cancel out.
Like?
3x squared.
2x.
Yep.
Anything else?
Not really.
And it should always happen that way. If you did do it correctly, all of your non-h terms, in other words, all your terms that do not have an h, they should all cancel out. So then I'm left with 6xh plus 3h squared plus 2h all over h.
You just take out an h out of everything.
And remember, in a show problem, you want to make sure that you show the actual factoring out of the h, not just the canceling of the h in every term. Okay? So make sure you show, as the limit as h approaches 0, that you factor out an h from each term. That way, the h on the top and the h on the bottom what? cancel out. So this becomes the limit as h approaches 0 of 6x plus 3h plus 2. And now I can evaluate the limit as h approaches 0. Because before, if I try to plug in 0 in for h, I would get 0 over 0, which you cannot have. But now if I plug in 0 for h, what am I left with? 6x plus 2. And 6x plus 2 is the derivative of 3x squared plus 2x.
Wait, so when we're at that final phase where we took out the h, we have to put in 0?
Mm-hmm.
Okay.
So now when we evaluate the limit, this basically becomes 6x plus 3 times 0 plus 2. And then that's how we get 6x plus 2. Which we should have known that's what it was from the beginning. From what rule of derivative?
Power rule.
The power rule. Now what is the, remember the power rule is when you bring the exponent down to the front and you subtract 1 from your exponent. There's also a constant rule, which basically says the derivative of a constant is 0. Constant multiple rule basically said that if you had a number in front of your function, then you just multiply that number to whatever the derivative is. And then, of course, the sum and difference rule, which says that if you have two things being added together, subtracted from each other, you just take the derivative of each piece. Okay? So real quick, what's the derivative of x to the 12th?
X to
11x.
11x.
Or 12x.
12x to the 11th. Okay, think. Derivatives, this is slightly different from integration. Remember, in integration, we added 1 and then divided by the new exponent. Derivatives, you bring down your exponent first and then subtract 1 after.
Gotcha.
So then that's your derivative, no plus c, just that.
Okay, yeah, I need to write this down.
No, plus c.
Alright, don't forget, make sure that if you have your special ones, your exponential ones, e to the x, derivative of that is e to the x. Ln of x, derivative of that is 1 over x. So if I look at 4 ln of x, what's the derivative of this?
Well, it's 4 over x.
It'll be 4 over x. Very good. What about this one when you have a constant in front of e to the x? What's the answer?
2.
It's still e to the x.
1 over x.
2 e to the x, and the ln of x is?
1 over x.
So then yes, this is the derivative here. Okay? That's the constant multiple applied at its finest. Okay? Product and quotient. Remember, they're not written like this in your reference booklet, but this is product and quotient rule. Product is the first times the derivative of the second, plus the second times the derivative of the first. Quotient rule. Y'all remember the saying?
Nope.
Bottom.
Remember it was low,
Low, D, high, high,
D high minus high, D low, all over low low.
Why does this feel like it's...
So let's do a few product rules and quotient rules, okay? Here, a very easy example. Remember, product rule is the first function times the derivative of the second. What's the derivative of ln of x?
1 over x.
Plus the second function times the derivative of the first. What's the derivative of 3x plus 1? 3. So then my final answer, once I distribute, becomes 3 plus 1 over x plus 3 ln of x. Yes?
Yep.
Okay. Do this one on your own. First times the derivative of the second, which was 2, plus the second times the derivative of the first, which was 4x to the third, plus 9x to the second, right? Okay? So you should add 2x to the 4, plus 6x to the third, plus 12. Then I had to FOIL that next part, which would have been 8x to the 4, plus 18x to the third, minus 4x to the third, minus a 9x squared. So then you should have had 10x to the 4, plus 20x to the third, minus 9x squared, plus 12. Yes?
What'd you get
So
Wow.
so 3 times 2, and then you have negative 4x to the third, and then plus the 18x to the third. Quotient rule. Let's do this one together, and then you guys will do one on your own. Remember, it's low, d high. So what's the derivative of the top?
5.
Minus high, d low. What's the derivative of the bottom? And please be very cautious, guys, since there's going to be multiple terms in that second part. You have to distribute that negative over. All over, low, low. And my thing to you was when it came down to the bottom, you always left it in that form squared or cubed or whatever it was, because if there was anything in common that could cancel out, you would know if it was in its factored form. So you want to leave it in this form. So it becomes 5x squared plus 5. I'm going to go ahead and multiply this out before I actually distribute over, so I don't want to mess up. So then I distribute over that negative to get 5x squared plus 5 minus 10x squared minus 6x. Can I combine like terms? So that's a negative 5x squared minus 6x plus 5. Can that factor? Are there two numbers that multiply to give you negative 25 that add together you need negative 6?
No.
So that's our final answer. Y'all remember quotient rule?
Yeah, what if we expanded the bottom?
You could, but you don't have to.
We don't have to simplify from here?
I mean, if you could, then you would, but you would want to leave it in its factored form to see if things could be simplified. That's why I asked if there were two numbers that multiply to give you negative 25 that add to give you negative 6. Because if the top can be factored, you want the factored form in the denominator. Okay? Don't let this throw you off. Okay? This notation just means what?
Derivative.
The derivative of t.
So you're taking the derivative with respect to t of this function, and it can be written in this form. So find the value of k. Do that now. What's the value of k?
3.
4.
All right.
You're wrong, Francisco.
First times the derivative of the second, plus the second times the derivative of the first, all over. Oh no, I'm thinking mixing quotient and product. My mistake. So e of t plus t e of t plus 3 e of t. You have like terms between e of t and 3 e of t, which gives you what? 4 e of t. And since each term has e of t in common, you can factor it out. And yes, k is equal to 4.
Wait, I just need to check a hot minute.
So use product rule. First times the derivative, second times the derivative.
Oh, okay. Thank you.
Alrighty. Let's take a look at this. It's not a pod. It's not a pulled question. So I want you guys to do it and do it well. So you have to write down the equation of the vertical asymptote. Remember, it's an equation, so it needs to be in a particular form. And vertical asymptotes are found when you do what?
Set the denominator equal to 0.
Very good.
Oh,
Denominator equal to 0. So x is equal to,
1/5.
and that is the equation. You need the x equals. Does everybody have the x equals?
Yes.
I have y equals. I have
X, because it's vertical.
You're wrong.
It's vertical.
You're wrong.
You're wrong.
You today. Hey, Jesus.
I mean, harsh, but true but harsh.
Derivative, okay, it's a quotient rule. Low, d high, 6x,
Yeah.
minus high,
D low.
which is
5.
all over.
Oh.
And there's how they get the 5x minus 1 squared. It's there. So we just distribute, so that gives me 30x squared minus 6x.
Minus 15x squared.
So the numerator turns into
15x minus 6x. Which is exactly what the question's looking for.
exactly. And what does this symbol mean right here?
All real integers.
Integers. Whole numbers, positive and negative. Very good.
Hey, I just want my Friday dress back.
Question?
I want to flex my purple.
Why is purple?
Yeah, I got to Florida Ball and they gave me a t-shirt.
I want to wear the college you're probably
You
not
good?
going to.
I got it.
Now I see.
It's like
Where
a
you going,
negative
John
15
Andrew?
plus
Huh?
6.
Where do you want to go?
But you have your
You
positive 30,
Why don't you see it?
and then your.
I set it up wrong.
I said that, but I'm just waiting.
Oh, you had it backwards. Remember, low D high, not high D low.
Y'all know when Mr. Krabs just raises the Krusty Krab sometimes? I'm gonna do that to my own house to find
Here we
my
go.
present.
Remember, chain rule. Okay, it's when you basically have like a composite function. So you take the derivative of the outside with respect to the inside, and you multiply by the derivative of the inside. Okay?
Yeah.
So do a couple together to refresh your memory. Now let's do some on your own.
Yeah, this is
But first,
Oh, is that dot a binary dot, or is that
Mhm.
supposed to be a multiplication sign?
It's supposed to be like multiplication, but I didn't want to put another set of parentheses because I thought that might confuse, and I definitely don't want to do the binary x because it might have confused as well. But
I see. Your veil.
When did we use the
Yo,
one
man,
with
I see.
the dot
I used
product?
that one.
With vectors.
Vectors.
What I saw. What I didn't see all
does everybody see the outside function?
I just saw.
Yeah, it's 4x to 6.
Right, it's basically like the 4x to the 6, so this is your inside function. What's the derivative of 4x to the 6?
24x.
But we don't put x, we put,
5x cubed plus 2.
you put the inside. Then you multiply by the derivative of the inside, which is,
15
14 squared. Yeah, that's it.
and then you multiply to simplify. What we're multiplying is the numbers on the outside with that function there for a final answer of what? What's 15 times 24?
That's a good question.
Okay, let's see. 24 times 5, that is 20. 120. This is big brain time. Okay, 120 plus 200, that's 320.
320?
Yeah,
Wait, is it 320?
I know.
I got
240, yeah, 360. Dang, I forgot to count for 40.
So it'll be 360, 5x to the third plus 2 raised to the, oh, sorry, x squared. So 360x squared times 5x to the third plus 2 to the fifth power. Okay? Here, we have another chain rule because this can be written as 4x squared plus 1 to what power? So your outside function is basically x to the 1/2. Your inside function is 4x squared plus 1. So what's the derivative of x to the 1/2?
It's 1 over 2 square root of x.
Which we can simplify there. But I don't write an x, which I just wrote, but I shouldn't write an x. What do I write instead?
4x.
Then you multiply this by
8x.
the derivative of the inside. Now when I take care of the negative, that brings this entire piece right here to the bottom. So now I have 8x over 2 times 4x squared plus 1 to the 1/2.
And simplify it to 4x over all that pizzazz.
Pizzazz.
Is that a real word?
Is that, I don't know, I just like it.
So it is.
And there you go there.
Nice.
See, it was the flex before the flux.
Questions?
Is there any way that you can?
Sounds weird.
Well, in these kind of problems, is there any way that they would expect you to expand the bottom?
No. Because a lot of times what you'll have to do is like find the slope at a particular point. And so you want, you'll plug in something for x and then go from there. Let's see. I want you guys to do. Nope.
Boom.
What you guys to do this one?
Ooh, fancy.
What do you get?
No, I can't.
Or e to the 4x.
Very good. Because the outside function is e to the x. Derivative of that is just e to the x. And then you take the derivative of 4x, which is just 4.
4. Dash was the number.
Let's do this one.
Ooh.
What's the outside function? X cubed. What's the derivative of that?
3x squared.
But I'm not going to write an x, I'm going to write,
ln of x squared.
It's a normal 3.
and the derivative of ln of x is,
Over x.
so my final answer is 3 ln of x squared over x.
Or it can be. Wait, I don't understand. If you take like the derivative of the 3 up there, wouldn't it just be?
Oh, remember,
so much
what do you mean?
better than it was the first time.
Goes to the front?
I'm just glad I'm getting all my derivatives. Comes back. This is
I
all
thought you had
cool.
to take the derivative up there. My bad.
Oh, you
Now-
think that they did it up to the.
Yeah, I think that's probably what you think.
Yeah.
Okay, let's do this one.
What is this?
So with this particular problem, it wasn't just product, but it was also a
Chain rule.
it was a chain as well.
The product chain.
You had your function x, and then you had your function that was inside the box. So when you did the first times the derivative of the second, the derivative was where the chain was. Because this can be written as 1 minus x squared to the 1/2. So your outside would have been 1/2 x to the negative 1/2. But remember, we always write the inside function. And then you multiply by the derivative of the inside, which was a negative 2x.
Do it.
So that was the first times the derivative of the second plus the second times the derivative of the first, which was nothing but 1. So when it comes to multiplying and simplifying, I'm multiplying x by 1/2 and by a negative 2x, which just turns into a
Negative 2x squared. I mean, negative x squared.
negative x squared that gets multiplied to 1 minus x squared to the negative 1/2 plus the square root of 1 minus x squared. And I can continue to simplify that some more as negative x squared over 1 minus x squared to the 1/2 or the square root of it. And that will be your derivative.
Oh, yeah.
Okay. Make sure not to reduce it too.
Just be careful when it comes to your multiplying, okay?
Totally 100%.
I think we
Sure.
Oh no! I
This
was
here is an example of a,
double chain.
it's a double chain, okay?
Double chain.
So your first function is e to the x. The inside function for that is 2x to the 4th. And then the inside of that is 3x minus 1. That's how it breaks down to be. So you take the derivative of the outside with respect to the inside. So what's the derivative of e to the x?
Yes.
But you don't write x, you write the entire exponent. Then you have to multiply it by the derivative. You have to take the derivative of the inside. What's the derivative of yeah.
8x to the third.
All right, but I don't write x, I write
3x minus 1.
very good. And then I have to multiply one last time by the derivative of the inside, which is 3.
Oh.
So then the two things that only get multiplied here are the 8 and the 3 to have 24. 3x minus 1 to the 3rd power e to the 2, 3x minus 1 to the 4th power.
Permission to take a quick picture.
Yes.
Big thing.